Hi, welcome back to Math Maxtra. This is Sarita. Today we will continue the last part, that is related angles. In the related angles we'll see some more types. So the first one is adjacent angles. Adjacent angles. So what are adjacent angles? See, in order to say the two angles are adjacent, we should follow three conditions. The conditions it should follow is the first one, the both the angles must have a common vertex. Must have a common vertex. And the second condition is must follow is they must have a common arm. They must have a common arm. And the third condition it should follow is the non-common arm. The non-common arms must be either side of the common arm. The non-common arms must be either side of the common arm. Either side of the common arm. So if the two angles satisfy these three conditions, then we can say those are adjacent angles. See, this is OA arm and this is OB ray and this is OC ray. See, this is one angle, we are saying it as alpha, and this is another angle, we are calling it as a beta. See, in order to say these alpha beta are adjacent angles, this figure must follow these three conditions. Okay. So the first condition is, we'll check the conditions whether it is following or not. Then we can say whether they are adjacent angles or not. The first condition is they have a common vertex. See, this angle alpha angle have a common vertex O, and this beta angle also have a vertex O. So both have common vertex, that is O. And come to the second condition. They should have a common arm. So the two angles must have one common arm. See, check. This alpha angle can also be represented as a AOB. This OB arm is common to both the angles alpha and beta. See, BOC. So the OB is common to AOB as well as BOC. That is why this arm is called OB arm is the common arm to both the angles alpha and beta. So, okay, second condition is also satisfied. So come to the third condition, that is the non-common arms. What are the non-common arms? This is OA and OC. These two are non-common arms because these two are different for different angles. So those are non-common arms. Those non-common arms must be either side of the common arm. So this we are calling it as a common arm. So these two non-common arms are either side and both must not be equal on the same side. Those two must be on either side of the common arm. Then we can say these are the adjacent angles. So it is satisfying these three conditions. That is why we can say alpha and beta are adjacent angles. And see this figure. And this is one angle alpha and this is another angle beta. Okay, this is O A, B, C. Now tell me whether these two angles are adjacent or not. See, what we have to check in order to say adjacent angles, these three conditions we have to check. So check, they have a common vertex or not. Yes, they have a common vertex O. And whether they have a common arm, check. Yes, for this alpha angle, OA is the common arm. For this alpha angle also OA is there, and for this beta angle also OA is there. Yes, it has a common arm OA. And check the third condition, that these non-common arms, this OB and OC are non-common arms. These two must be either side of the common arm. But when we come to this figure, these non-common arms are both or on only one side of the common arm. That is why it is failing to satisfy the third condition. We don't say these are not adjacent angles. These are not adjacent angles. These are not adjacent. These are adjacent. And check one more figure. This is alpha and this is beta. This is O. This is some P, Q, R, S. See, check whether these two angles alpha and beta are adjacent angles or not. Check the three conditions. That's it. See whether they have a common vertex. This angle alpha has a vertex O and this beta angle have a vertex P. So they don't have a common vertex. The first condition itself failed. That is why we say those two angles are not adjacent. So these two angles are not adjacent angles. Not adjacent. So this is how we identify whether the given angles are adjacent angles or not. So this is one type of related angles. And we'll move to the next one, that is linear pair of angles. The second one is linear pair of angles. Linear pair of angles. So what are linear pair of angles? So in the previous adjacent angles, we have seen that must satisfy three conditions. In the similar way, in the linear pair of angles also, it should satisfy two conditions. So the first condition is the two angles must be adjacent angles. The two angles must be adjacent angles. Nothing but it should satisfy the previous three conditions. Those two must be adjacent angles. And the second condition, the sum of the two angles, these sum of two angles must be equal to 180 degrees. In other words, we can also say that two non-common arms must be exactly opposite in direction. Those two non-common arms must be exactly opposite to each other. So then we can say those two are linear pair of angles. See, check. This is angle alpha and this is beta. Okay. O, A, B, C. So these two angles. So in order to say these alpha and beta are linear pair of angles, we have to check these two conditions. Check whether the first condition is satisfied or not. Now what is the first condition? Adjust those two angles must be adjacent angles. Check whether they have a common vertex. Yes, they have a common vertex. Whether they have a common arm. Yes, they have a common arm OB. And whether the non-common arms are either side of the common arm. Yes, OB is the common arm and OA, OC are on either side of the common arm. And check the, okay, first condition is satisfied. They are adjacent angles, confirmed. Then the next, move to the next condition, that is A plus B must be equal to 180 degrees. So here alpha and beta, whatever may be the angles sum must be equal to 180 degrees, or in other words also we are saying these non-common arms, these are non-common arms, right? These are exactly opposite to each other. When they are exactly opposite to each other, the angle thus formed is a straight angle which is 180 degrees. So that is why we are saying this sum of these alpha and beta which is equal to 180 degrees. That is why these two angles we call it as a linear pair of angles. See, check whether these two angles are linear pair of angles or not. See, this is one angle and this is one angle A, D. Check. See. So you check the first condition whether they are adjacent angles or not. Okay, they have common vertex, but they don't have a common arm. If they don't have a common arm, we don't say them as a adjacent angles. So that is why, so it is not satisfying the first condition. These are not linear pair of angles. The above one is linear pair of angles. The below one is, it is not a linear pair of angle. It is not a linear pair of angles. So this is how we check whether the given angles are linear pair of angles or not. And we'll move to the next one, that is vertically opposite angles. So the third one is vertically opposite angles. Vertically opposite angles. See, what are vertically opposite angles? See, you take two straight lines. This is one straight line and this is another straight line. If the two straight lines intersect at one point, okay, there, this is one straight line, that is L, and this is another straight line, that is M, and these two are intersecting at this point. So when they intersect, when the two straight lines intersect, the four angles are formed. This is one angle, that is alpha, this is another angle, that is beta, and this is another angle, this is gamma, and this is another angle, that is delta. See, the four angles are formed. So what is the definition of vertical angles? The angles which don't have a common arm, the angles by forming when two straight lines intersect, the angles thus formed which don't have a common arm, that angles we call it as a vertically opposite angles. See, check whether alpha and gamma have a common arm. See, this is the vertex and these two are arms of the alpha angle and these two are arms of the gamma angle. These two don't have a common arm. That is why we call these two angles as a vertically opposite angles. So alpha and gamma are vertically opposite angles. So these alpha and gamma are vertically opposite angles. In the similar way, see this beta angle, these have a two different arms, and this delta angle, it also has two different arms. So these two angles don't have a common arm, and those two angles are formed by intersecting two straight lines. Thus, that is why we call them as a vertically opposite angles. The theorem, we have a one theorem, that is two vertically opposite angles are always equal, and we'll see that proof in the coming videos. So we'll just remember the statement now. The vertically opposite angles are always equal. See, this alpha is equal to gamma because these two measure the same magnitude, and this delta which is equal to beta because these two are also vertically opposite angles. So this is how we define the vertically angles are. In the exam they ask they very often they ask the questions based on these type of related angles. Means they give you one angle, and they will ask to find out what is the complementary angle of that given angle, what is the supplementary angle of the given angle, and they give the relation between complementary and supplementary. So we have many ways to ask the questions from this topic. So that is why these related angles are very important in the to solve the questions in the geometry. Okay, thank you.